friends, we now come to a very important address. Dr. Shenggen Fan, who is with us, who is the Director General, International Food Policy Research Institute, Washington, D.C., USA, is going to address us. I invite you, sir, to the podium.
Okay. Well, actually, this is my first official event in 2013. So the first presentation. Really a pleasure to be here. I have been traveled to India many, many times. I stopped counting after 20. But in the last several years, I have reduced the number of travels to India because I have a global mandate right now. So I'm traveling more to Africa, to South America, Europe, so less so to India. So I try to change myself. So I arranged my first trip in 2013 to India. So thank you for your invitation. I think as many speakers said that the conference identified the very right topic, that is how can we really promote agriculture production sustainably for food and nutrition security. So all this combination of buzzwords together is a must. So I have three key messages for the audience here. Number one is food, nutrition security, and poverty are still persistent in India. Second, the current and the future challenges threaten Indian food security as part of the global food security challenges. And finally, we must to take an innovative and integrated approach to improve food and nutrition security in sustainable manner. Here I must say that I have lots of colleagues sitting in the podium and as well here, as well as in the audience. Professor Swaminathan has been a leader in the global agriculture research system, the Director General of IRRI, my sister center. So now I'm leading another center of International Food Policy Research Institute. So we work together as a partner as well. So we are working on a project called Transforming Nutrition. So Swaminathan Research Foundation is a partner. And Professor Sin, I have always enjoyed your talk. You might remember that you came to one of my very first seminar I had here in India, maybe 15 years ago. Obviously, Professor Aryappan is not only our partner, but also a donor. So the strong intellectual support and financial support to the whole CGIAR and the IPRI is very critical. Although that part is small, we're expecting that part will continue to rise. And obviously, I thank NIAS for organizing this great conference, Professor Shetty for your great invitation, and Professor Rama Murthy for leading such a great institute, 25 years old now. Now, the poverty and hunger declined in India and China, in many emerging economies such as Brazil and Indonesia. But it is still the case today that China and India still have large number of poor people. So India has more than 200 million people who still live under $1 per day, and China has more than 100 million. And the rate has come down dramatically, but in the case of India, more than 40% of the population still earns less than $1 per day, and China probably about 10 to 15%. And more importantly is the rate of hunger. So based on the trend we have had from 1990 to 2010, we are not on track. So India is not on track in terms of cutting the rate of hunger by half. And I think India and Brazil have been doing better, so they are on track. In fact, both countries have met the Millennium Development Goal number 1 before this schedule. So India is the only country among the major emerging economies that has not met the Millennium Development Goal number 1. And as many have shown that the current level of hunger in India remains alarming. So this is very ironic. So India has experienced rapid economic growth for the last 20 years, 6% per year, then accelerated to 8%. 1 year is almost 10%. Even agricultural growth has been very decent. I think Professor Sen has indicated that in the last several years, the agricultural growth has been accelerated. But there is a disconnection between agricultural growth or overall economic growth and an improvement in hunger reduction or malnutrition reduction. And one dimension of the hunger is so-called hidden hunger, lack of micronutrients, vitamin A, iron, zinc, all these minerals our body needs to enhance our mental and physical ability. And India is one of the countries that is experiencing extreme level of deficiencies in micronutrients. So very high. And the current and emerging challenges exist. I think based on the current trend, China and India will consume large amount of food. By 2030, China may import more than 100 million metric tons of grains, in addition to the current import of 60 to 70 million tons of soybean, 2 to 3 million tons of maize, 1 to 2 million tons of wheat, and even for rice, China is importing 1 to 2 million tons. So in 2012, China, 2012 was a turning point for China. China has become a very sizable importer of food. So here my key message here is, yes, China and India will face challenges, but we have to think the challenges beyond our own country boundaries. Can we think of international market to feed ourselves? So based on current trend, if both countries import more than 1 million metric tons of grains by 2030, how can we feed our population smartly? I think many, Professor Ayyappan used the not so smarts. How can we feed our population smartly and efficiently, effectively, using natural resources, or not causing natural resources degradation is so critical. The climate change will hit us soon and very hard, and this is a reality. We have to take that into consideration. So population is increasing. Urbanization is a factor that I think the previous speakers has not mentioned, maybe hinted. India will become more urbanized, and at that speed will accelerate in the next 20 or 30 years. We expect that by 2050, India will have more urban population than rural population. So my own country, China, again, 2011, 2012 is a turning point. So in these 2 years, China actually has more urban population than rural population. So urbanization rate is more than 50% in China. I think India will catch up very soon. So by 2050, maybe even before that, the urban population will be bigger than rural population. The total population, India's population probably will peak around 2050, if we use the conservative or medium conservative projection by the UN. So the population will peak around 1.6 billion. However, if we do not have the right policy, that population could continue to increase, could probably explode. So the tremendous pressure from the population growth. On the other hand, natural resources base have declined over the last several decades. India is one of the countries where the soil fertility has been lost the most, so among one of the countries. If you look at that correlation there, you will see it is some of the poorest region where the soil fertility has been lost the most. So parts of China, parts of India, Africa, Latin America. And that trend probably will continue if we don't pay much attention to the land issues, land degradation issues. And it is not just in some of the dry area that land degradation has occurred most severely. In fact, it is irrigated areas. So Punjab, Haryana has lost a lot of fertile soil or topsoil. And southern China, northern China, and parts of Africa. And water stress is coming to us and has come to us and probably will be much more severe in the future. So majority of India will have very extreme index of water stresses in the next 20 or 30 years. Now the climate change vulnerability is very high in India and China. If we just look at the direct risks, you will see that China and India actually account for the largest share of the most extreme vulnerable regions because of the climate change. And in terms of coping ability, both China and India can do better than Africa. But even by taking into that consideration, both countries are still vulnerable to climate change. Now, agriculture growth in India has been very strong. 3%, 4% per year during the Green Revolution eras. It declined to 2% in the 90s, maybe even in the 2000, the first decade of the millennium. In recent years, we have seen some acceleration, but that percentage is not high enough. 2% is not enough. And there is a need of much higher growth. And in the past, majority of the growth come from the use of inputs. The total factor productivity accounted for some growth, but not as high as some of the countries like Brazil and China. And part of the reason is because of the government support in inputs in existing agriculture, in providing subsidies to inputs, and not necessarily in providing investment in agriculture research, so use technology to increase production and productivity. So what we need is an innovative and integrated approach. So 5 elements of this approach. One is to continue to invest in rural infrastructure, agriculture research, and education. And that investment has to be accelerated in the future. The second is to promote sustainable intensification of agriculture growth. So intensification is a must, but how we do it is a challenge. And to promote smallholder-friendly innovations and high-value markets. And leverage smallholder agriculture for better nutrition and health. The nutrition and health are final outcome objective we wanted to achieve. Agriculture is only an instrument. And finally, scale up productive social safety nets and linking that to nutrition and health. So IPRI studied together with some of the Indian colleagues, Ashok Gulati, Professor Thorat, have really shown that investment in agriculture research have high returns in terms of both promoting agriculture growth, food security, as well as in terms of poverty reduction. Look at the top of the table. So for every 1 rupee invested in agriculture research, 7 or 8 rupees will be returned, even in the 90s. And the returns in the 60s were even higher. So $1 or 1 rupee invested in the 60s or 70s, almost 20 rupees were returned. Although that return has declined over time, we call it a marginal return, but it is still very, very decent. So 7, 8 times. Followed by education. Actually, I made a mistake. The agriculture research investment actually has almost 10 rupees return. It's not the 7 or 8 is returns in roads investment. So agriculture research has the highest return, followed by roads and education investment. Then in terms of poverty reduction, the agriculture research also has the second largest return, next to roads. So the bottom line is investing in agriculture research has high returns in promoting agriculture growth, in promoting food security, in promoting poverty reduction. But if you look at the investment in agriculture research, India has not done very well in the last 2 or 3 decades. Look at the charts of Brazil, particularly China. So for the last 3 or 4 years, China doubled its agricultural research investment. And in fact, China accounted for 30 or 40% of the global increase in agriculture research for the last 2 or 3 years. And Brazil has also accelerated investment. And I think so did India in that chart. But if you look at the percentage of the investment or the agriculture research investment as a percentage of agriculture GDP, so relative to the size of the agriculture sector, so you will see Brazil has almost double or 3 times the level of India and China has. So we call it the research intensity ratios, so the percentage of agriculture GDP. In Brazil, it's 1.5 to 2%. China, India, is about 0.5%. And on average, at a global level, right now it's about 0.6 for developing countries, 2 to 3% for developing countries. So we have a very far way to go. And look at the productivity growth. The very right chart, you will see the total factor productivity growth in China, India, Brazil, starting from 1960, so 61 to 2009. The total factor productivity measures the growth of output, net of growth in input. So this is the growth we really want. And the future intensification must depend on growth in total factor productivity. For the last several decades, both Brazil and China have experienced 2%, sometimes 3% growth per year. India is only about 1%. So, which also shows that India has great potential, much greater potential to catch up. So if India can increase the total factor productivity by 1% per year, in addition to 1% right now, to 2%, 3% per year. So you can easily, not easily, you can increase your total production growth not through increase in inputs, through a more efficient use of inputs, through improvement in infrastructure, improvement in agricultural research, and therefore technologies. And promoting sustainable intensification, it is a must. It's not just a buzzword. We do need to increase our food production, agriculture production, to meet various demand: food, feed, fiber, and fuel. 1 F less than Professor Ayyappan. So you had 5 Fs. I forgot which other one, maybe 4 of. And preserve natural resources, including biodiversity, and reduce agriculture greenhouse gas emissions. So for all these reasons, we have to promote more sustainable intensification of agriculture production. Now, how do we support sustainable intensification? And resources inputs and output must be properly priced. I have to emphasize properly priced. So sometimes, because of government policies, because of other lack of information, the input-output prices are not properly priced. If they're not properly priced, the wrong signal will send the wrong incentives for farmers to use the inputs. So they could overuse certain inputs beyond the optimal level. Let's say over-subsidization of fertilizers, over-subsidization of irrigation water, or over-subsidization of electricity can lead to overuse of these inputs beyond the optimal level. So if these inputs are properly priced, then suppliers can also have incentive to improve their services. So more reliable supply of electricity, better quality of fertilizers, and more reliable supply of water. And technology innovations will be so critical in improving these efficiencies. So in addition to getting the prices right, so innovation will be so critical. So new innovations have to focus on improving efficiency of inputs such as water, land, energy, and fertilizers. And increased support of agro-processing and cold storage facilities. From our own estimation, a recent study between IPRI and the Indian collaborators showed that 20%, 30% of food has been wasted in the supply chain. So by improving the supply chain, that wastage can be cut substantially, in addition to improving nutrition. And finally, to promote win-win-win strategies for climate change adaptation, mitigation, and increased productivity. So there are certain policies and institutional innovations, technology innovations that can help to mitigate the climate change and obviously adapt to climate change and improve productivity. So smallholders will be able to gain from that. The number 3 is to promote smallholder-friendly innovations and high-value markets. Some of the innovations that have to come from non-agriculture sector. I think Professor Sen has indicated or hinted at that. Many innovations in agriculture sector could come from non-agriculture sector. Mobile phones, banking, insurance, and using modern communications to communicate certain information to farmers. So for your information, IPRI is working with ICCC and Tamil Nadu Agriculture University. I don't know whether Professor Ramasamy is here, to use the internet to communicate the extension, the technology, market information to farmers by using internet, by using mobile phones. So the critical element of that service is the content of the information we will provide to farmers. I think the audience here can provide a very critical role in providing the good content to farmers. The insurance institutions, I wanted to come back to the importance of institutional innovations in promoting intensive agriculture growth or intensification of agriculture growth and high-value agriculture production. So Operation Flood here in India, you must know, has provided a quiescence for everybody, not only in India, but also at a global level. So the strong government support, the cooperatives, the federal level, state level, and even down to community level, played a huge role there in promoting technology, in promoting smallholders, small dairy holders to market. Look at the results. So from 1980 to 2007, 2008, the milk production has grown at 3%, 4% per year. And the per capita consumption of the milk has increased at a similar rate as a result. So that has really improved the nutrition status of many Indians. Now, leverage agriculture for better nutrition and health. This is not a new topic. It was debated at least in the 80s, 90s in the CGIAR. CGIAR actually had a network, a platform, and trying to link agriculture to nutrition and health. But the real change happened in the last 2 or 3 years. The scientists in the CGIAR, in the National Agriculture Research System, begin to pay attention to that. I think we created a wave in linking agriculture to nutrition and health. In February 2011, IPRI and the Indian partners, Indian government, co-hosted a conference on linking agriculture to health and nutrition. Many speakers, including Professor Swaminathan, made a great keynote speech there. The Prime Minister of India came. So we created a wave. So as a result, the CGIAR launched a new research program. So CGIAR used to be crop focused, or breeding focused, or technology focused. But this time around, CGIAR launched a first program on nutrition, on health. But not just nutrition and health per se. The key there is linking agriculture to nutrition and health. And after that, with the support of the Gates Foundation, with the DFID, several initiatives have been launched here in India, including the one I just mentioned, the collaboration between IPRI and the Swaminathan Foundation in transforming the nutrition, and agriculture has a key role there. And well, that link involves many dimensions. One is simply to diversify agricultural production away from staple crops. We know that rice, wheat, maize, potato provides energy, provides calories, but usually they are very poor in terms of nutrients, vitamin A, iron, and many other minerals, and lack of protein. So one simple solution is to diversify the production to pulses. I'm glad that our Equisat, the leader on a legume breeding program, is here. So legumes, vegetables, fruits have very high intensity of micronutrients. So one way is to diversify the production. So we have seen some trend. This is a similar chart to Professor Ayyappan's. So for the last, there's 2 decades, we have seen diversification here in India, but the pace is not fast enough. We wanted to see much greater pace. Just for your information, in the case of China right now, the cereal production only accounts for very small parts of total production, maybe 20 or 30%. Fishery, huge increase to 15%, and livestock to 30%, and fruits and vegetables, huge increase. Well, partly because of the rising urban income, partly also because of transforming the whole agriculture sector away from cereal production. But in that process, cereal production has not to sacrifice. So rice, wheat, and maize production continue to increase. It is just the case that the production of fruits and vegetables, livestock, and fishery have grown much faster. And enhancing nutrition through biofortification, again, this is another important dimension of linking agriculture to health and nutrition. We know that many poor, particularly poor farmers, will continue to eat stable foods like rice, wheat. So very difficult for them to diversify their diets in short run. And one cost-effective solution is to integrate the nutrition, integrate the micronutrients into different crops through breeding. We have seen many successes already. In Africa, the so-called orange sweet potato, have very high vitamin A's. That's 40% to 60% of children in Uganda, in Mozambique, are eating biofortified sweet potato. So their vitamin A intake has doubled because of that. We have also made some limited successes in cassava, in maize. Here in India, the collaboration between Harvest Plus, the pre-net program, Harvest Plus, AJ, I think Professor Swaminathan was part of the advisory committee. So the Power Minute was a result of the collaboration between IPRI-NET, Harvest Plus program, and Equisat. And the potential is huge. Not only rice, maize, wheat, it can go to many other crops. And even within the rice, not only nutrition, but also health. Some of the Chinese scientists are looking for certain genes that can help to reduce the starch of rice, increase protein of rice. So the people who have diabetes or people who have tendency to become diabetic can eat that type of rice. So not only nutrition, but also direct health consequences from biofortification. A scale-up of productive social safety net. I should really congratulate the Indian government, particularly under the leadership of Swaminathan on this food security bill. Everybody in this world deserves nutritious food, deserves access to nutritious food. So food security bill will help every citizen in this country have access to the food. Obviously, we can debate what will be the best way, whether through research, through production, through increased income, or direct subsidy. I'm also very glad to hear that the Indian government will scale up the social safety net or cash transfer. My only recommendation there is to make sure that the cash transfer links to nutrition and health, to build the population's long-term human capital, and link that to production, particularly smallholders. If the social safety net can also link to productivity enhancement, then you have many wins. So wins in production productivity, wins in poverty reduction, wins in improving nutrition, wins improving let's say their short-term food needs. We have some evidence from Ethiopia. During 2009, 2010, the Horn of Africa experienced severe drought. In 60 years, the most severe drought in 60 years. So many people suffered from hunger and malnutrition. 16 million people in the Horn of Africa, Somalia, Kenya, and Ethiopia. But the impact on hunger poor varies by country. It is Somalia that suffered the most. It is Ethiopia that suffered the least. One of the reasons is because of the social safety net implemented in Ethiopia. It's not just simply cash transfer or food aid. That safety net has a very important component to make sure that smallholders, small farms can graduate from poverty, from hunger, by increasing their agricultural food production. From our own estimation, 6 million people were avoided falling into a poverty trap during the 2010, 2011 drought. I think India, it's great that India has launched that program, but it will be very important to make sure that that cash transfer can be used to set up social safety net, can be used to enhance nutrition and health, can be used to promote long-term food production productivity at the household level. So in conclusion, India still faces challenges in feeding its population, particularly in longer run, and more importantly, the nutrition and health challenges. And innovation, integration is a must when we move towards our future agenda. So let me thank you very much for your listening.
We now begin technical session 1. It is my proud privilege to invite Padma Shri Dr. M. Mahadevappa to kindly take the chair of the chairman of the session on the dais. Dr. Mahadevappa. Rapporteur, Dr. R. M. Hegde. Chairman, Research Management and Coordination Unit, Indian Institute of Horticultural Research, Bangalore. Dr. Hegde, sir. I now hand over the proceedings of this session to Dr. B. Narayan Swamy, Senior Scientist and former Head, Central Horticulture Experimental Station, Chethalli, now with the Indian Institute of Horticultural Research, Bangalore. Dr. B. Narayan Swamy, please.
Thank you, Madam. Most respected delegates, it is our privilege to have first technical session, which is chaired by none other than Padma Shri Dr. M. Mahadevappa. As you know, Dr. M. Mahadevappaji is a former 2 terms Vice Chancellor of prestigious Agriculture University, Dharwad, and also later he became Chairman of ASRB, New Delhi. In his credit, he is having so many awards. Apart from having Karnataka Rajyotsava Award to Padma Shri from the Government of India. He is basically rice breeder, as everyone knows.
Kindly condense this part so that we can save your time.
Okay, already it is delayed.
Yes.
With the permission of the chair, we are inviting on behalf of you, Dr. M. Mahadevappaji, to chair this session. Our rapporteur is none other than Dr. M.R. Hegde, is at present Principal Scientist and also Chairman of the Research Management Unit of IIHR Bangalore. In his versatility in different capacities, he has worked in ICR system from senior scientist and KVK head, and also in different parts of this country he has worked. At present in extension system also, being agronomist in extension system also, he is having well-versed experience as a zonal coordinator and also head of the division extension. At present he is a Chairman of Research Management Unit in IIHR. We are requesting both of them to handle this session. Over to Chairman, please.
Thank you, Dr. Narayan Swamy. This first technical session, immediately after a wonderful lunch, will certainly be giving some trouble to be 100% attentive, I am sure, with the delicious food we had. I welcome all of you, all the distinguished audience, I welcome. And I welcome my co-chair, rapporteur, Dr. M.R. Hegde, and also the distinguished speakers. The first speaker in this session is Dr. Sapan Kumar Datta, Deputy Director General Crop Science, ICR, whom it will be artificial if I introduce him to anybody here, because everybody knows him so well through his science contribution and so many other things. He has been serving in ICR even before that in the science. He worked in IRRI, and he's a very well-known scientist across the globe. I have the pleasure of chairing the session in which he is making presentation. Dr. Datta, may I request you to make your presentation?
Good afternoon, Dr. Mahadevappa, the chairman of the session, as well as Dr. Hegde, who is also be with him, and many of my senior scientist colleagues, fellow scientists, and now I see I'm lucky that Professor Abhishek Sen now would have to listen to me, some of the issues, what I like to throw it out today, this evening after lunch, and also all fellow scientists at ICR as well as at universities. So this is the title actually given to me, and I tried to put up some of the issues and challenges that how I like to see it. Many of the things that in the morning session, a brilliant session that you already heard, and listened to all of these issues, example, growing water scarcity, low productivity, crop soil and post-harvest loss, farmers' perspective, smallholding farms with a poor income, and climate change. This is another added issue. Food security bill, there is some sort of issues coming up, whether that would help the things what we desire, or that would create a different kinds of problems eventually. And of course, the biodiversity, an issue that how we like to see and use it. And to me, the one bigger challenge is smallholding farms with the global agriculture pressure. And I have a few slides to elaborate on that issues. And many cases, it's not science, it is a trade issue, whether it is in Europe or it is in US or even in Latin American countries. And in Science Congress, there was a session on suicides, and definitely to me, suicides is a social and a very long inherited social problems. Of course, agriculture can play a role, but not everything that agriculture can solve the problem of the suicides. As Professor Abhishek Sen mentioned in the morning session, that last 5 years scenario, that last 3 years particularly, we're doing very well in cereal grain production in spite of the fact that the drought and other challenging issues are there. But what he didn't say, what I like to tell you, that the last 10, 15 years of the scientists, our old senior scientists and the fellow scientists, have done some contributions that developed new genetic resources, or the policymakers, where planning commission members are also responsible. They've given right policy support, and that result is translation of science into farmers' field and its economic benefit, what resulted in the higher production and productivity that what we see today. But to maintain this and to continue this, we have to invest much more money in science and agriculture, and particularly science and technology, so that in spite of the climate change, in spite of all other difficulties, we can continue producing more, or we can develop a designer crops that crops can sustain in all adverse conditions. And that is the reason the funding is very important that to be invested. Even we are today what we are, but still there is in next 10, 15 or 20 years, there is a much more required in case of rice, 45%, wheat 38%, pulses 140%, and oilseed 243%. And what is not here in the fodder and forage crops, we are 61% deficit today. And if we want to produce higher milk productivity and other things, definitely we need to invest and we need to expand your research and extension work on fodder and forage crops, and which is definitely a daunting task that ahead that we have to solve. Now, one of the things that we often and always rather try to solve our problem just by integrated livelihood, where everybody is dependent on somebody and something, including subsidy, including different kinds of support, that somehow agriculture survives. And we think that we are doing very well. But at the same time, what I mentioned, the agriculture and global issue and global trade, which is a much bigger picture, where Brazil, Argentina, US, and many other countries, and China, and they are making a different kind of agriculture, which is large holding farms, mechanizations, and all modern agriculture input they are putting into the system. And that's the way they're looking at different agriculture with a higher productivity and income generation and the outcome. Where in that condition, how our small holding farms with integrated sort of approach can fit, in spite of the fact that our 80% or I would say 90% or more even, all are small holding farms, where there is a need of a big changes or big time or challenges needed to change that transition. We did not have a kind of bullet to show that from 1 ton to 5 ton, one jump. It never happened like that. But I believe that probably in future, another such green revolution, what Norman Borlaug was successful or were lucky actually, what happened with this, accidentally those genes were involved in that breeding program, and suddenly dwarfing gene was incorporated, and with the certain combination of the plants it happened. But we definitely can look into the new generation of science. I would come in a minute. It is possible that at least we can, the present productivity, if we can sustain with the further this type of increment, I think that would be the best sustainable agriculture we could think about. Now, one of the issues that the seed production, which is for a last, I think I would say 1 decade, there was a good program that ICR took over. There was a seed mission has been incorporated in the program. All state agriculture universities were involved in this program, where the breeder seed to foundation seed and ultimately certified seeds that ultimately reach to the farmer's field, and that we see at the outcome. Although there is still, in a few cases, there are some mismatch, but this is, I think, a very successful program. We still can improve it, that we're looking in 12 fiber plan, some referral quality seed lab, where even any dispute can be solved in those quality seed lab, and also can ensure the quality seed is given to the farmers in spite of whatever certification is given to them. So we want a scientific kind of understanding of ensuring and assuring our farmers that they are provided the quality seed. And this would be very much based on modern science. It's not just based on seed germination. So this is one thing that we would be incorporating into a 5-year plan, and so that everyone, including company, would know that if any seed or any particular certified seed even, 2 times I mentioned, I don't want to elaborate on that, but that can be challenged and scientifically we can give the answer. Now this is the issue that even we are doing very well as far as the data shows that our production, our storage, everything is great. But then the $50 million market, and just you concentrate on that one, $50 billion US dollar market, and our contribution is, India's production is 2% and India's export is only 1.6%, where a few other countries are controlling entire seed market. So when our farmers are producing enough or producing well, and when our scientists are doing their job well, and then ultimately it is not going to the market. If it is not going to the market, and if it is not contributing to the market, either we are not producing enough quality seed, or we do not have the infrastructure of entire management of this marketing, or we must think something how we can address that issue so that the production that what our farmers are doing, they have better access to the market so that they can fetch more money. At the same time, that could give a better return to them. Only one exception is the BT cotton. The last 1 year or the last 10 years, it is more than $9.5 billion it earned the market from the market, and last 1 year it alone $2.5 billion. And see, this is one thing that shows that if there is a interest, if there is a market strategies, if there is a quality seed production, and entire things, when they place together, it works quite well. So I think this is one possibility. We must look at how this can be addressed. Now, biofortification, which is the nutrition-enriched food available for the people, is a very important component. Professor Swaminathan's, I've been listening to him for such a long period of time. Always he advised us the right direction and advised us the certain things that we should be looking, we should be working. And also the Harvest Plus program, I was myself also was involved at IRRI when I was there. So I know this program, and the problem with this program, we have plenty of very good material. Either you take it even today's millet with high iron and zinc, or KPM maize, or sweet potato is Indian sweet potato, even much more dark color potato is available here. And many of the other, that mamordica as well as drumstick and many other materials which are highly nutritious. The only problem is because of our countries, the poor people are malnourished and they do not have access to this kind of food basket where plenty of good other nutritious rich foods are available or vegetables are available. They would be looking for staple food for their need of the stomach to fill up. And that is rice and wheat. And that's the one reason for maybe, I just need to be very careful about my statement. Maybe next 10, 20 years, still they will be more dependent on rice and wheat, because today we have our CRRI reported there is a good rice variety now. They have now incorporated in the high-yielding variety, have 10% protein, 10% protein, even in Sharno background. We would like to see a staple food crop that has high iron, zinc, as well as the beta-carotene and possibly folic acid or low phytate. So a combination of those kind of things with a protein background and a kind of high iron, kind of beta-carotene and other nutrition. And with the low phytate, I would show one slide why I'm emphasizing on low phytate. That probably can help immediately to our people who need them most. And gradually, when people are having their money, power, or they can access to the market and whatever, even non-veg and all other sources, and we don't need to talk about it, they can take their decision. This is something with the high iron rice that shows the iron does have iron, rice does have iron, But after polishing, this iron completely removed. So if we can take a brown rice, it contains very high iron. But as we take polished rice, it does not have the iron. And that's the reason this rice was engineered with a ferritin gene driven by a tissue-specific promoter that expressed in this endosperm. So after polishing, also we can see the high iron content in this material. Professor Swaminathan Foundation also has contributed work on this particular area. Now, one of the things that why we're talking about low phytate rice is required. The phytic acid, particularly phytic acid as present in all plants, it binds all minerals, including iron, zinc, phosphorus. So the food that we consume, it does not contain much of the iron because it is not available to us. It binds with the phytic acid. If we reduce the phytic acid with the MIPS and as well as IPK1, these two enzymatic pathway, if we can change this enzymatic pathway or silencing this pathway, resulting low phytate or low phytic acid, and that would allow more phosphorus to be available for the plants. It also would help the soil. At the same time, the iron and other minerals that would be available for our consumption, which is very good. And we have seen that all of the work that what is coming up today, from Calcutta University, this studies has now been conducted. It shows clearly the high iron and zinc rice does not compromise any nutrition pathway of that plant. So that means from substantive equivalence point of view, these are the metabolic pathway or metabolic engineering would help our generation new material, and that would be helpful for our nutrition improvement. The climate change definitely is an important issue, and I think one of the things that looking for the different allele mining, many genes, many allele present in the plant, we just need to map them, and those can be conferring tolerance to the either salinity or stress of climate or temperature or even drought. MSSRF also recently published a paper that taking genes from Abyssinia, Dr. Ajay, Abyssinia, and the transcription factor gene, and that gene incorporated in rice and tobacco that shows that conferring resistance to salinity. Similarly, this work has also DREP genes, another transcription factor genes available from rice as well as from Arabidopsis. A collaborative work with Japan and Calcutta University also showed that these genes can give rise drought and both salinity tolerant. These plants are surviving in this dry condition of the pores for 6 weeks without any water at the vegetative phase. So this can be extended also another week in the reproductive phase. And how it does it? It's a very simple thing. This transcription factor gene, this one master gene, triggered the stomatal aperture. In the control plant, the stomatal aperture remains open, so the water transfer, water evaporates from the plant. In the transgenic plant, this aperture remains closed, so the water does not go out during the daytime. And that's the way the plant retains the water in the system. So plant perceive the signal, what is required for its own survival, and it overexpressed or mediated by a particular gene or overexpression of that gene, ultimately plant will survive. And this work not only for rice, many crop plants, wheat, maize, and all the crop plants are coming up, including cotton. They are putting those genes into those plants so that even if the monsoon comes late or the water irrigation, particularly rain-fed lowland system, when the water is not available, plants can survive to some extent for a period of time. And then with the set of water, it can be solved. Now, one of the things that irrigation, and particularly to me always, I think the water is the critical factor for our agriculture productivity challenges to solve. And many of those, it doesn't show much better color here. The red color, and it shows very clearly that some of those red or zero, it is in the red color, or the blue color, Bihar, Chhattisgarh, West Bengal, they have plenty of water. Their water is not exploited. And many of the states you will see, Punjab, Rajasthan, Tamil Nadu, even Karnataka also overutilizing the water that is available. So I think this is one thing that we must understand. Even one India, we have a very diversified condition. We must understand which state or which zones have more water available, where it is not available. Accordingly, we may think about what type of crops should be grown there, what type of crops can be used as intercropping when there will be rains, and we can redesign the entire agriculture, although it is very, very difficult. Even in Punjab, for a long time we are talking to Punjab not to grow rice, but still they are growing rice because it's very productive for them. But considering the overall interest of the country, and overall condition of the soil, fertility, as well as water availability, we must think that how we can incentivize certain state to grow certain crops, and so that we can get the best potential of that crop can come from that state. Similar thing for the fertilizer consumption. That's I think many of the states either overutilizing the fertilizers or even lower utilizing the fertilizers. And neither way it is the right thing for us, because if the soil carbon content of the soil is not adequate, all the minerals that are fertilizers given to the particular soil would not be absorbed. That's the reason in majority cases 35% of the fertilizers are absorbed and remaining are not absorbed, or rather wastage. So we need an understanding of the entire, again, the India's map and the particular crop where it is grown. The carbon content of the soil is very important. Based on that, we need a mathematical calculations that which crop needs what amount of fertilizers and particular condition, what are the other things can be added, particularly boron and zinc. In some cases that can be supplied externally and can change tremendously of our soil fertility as well as crop productivity. Now, one thing recently came from IRI's work, that they put a gene in rice, and that gene also available in the rice plant, and that shows that this plant can survive in the phosphorus deficient soil. It has a better uptake of the phosphorus from the soil, so that that phosphorus is utilized by the plant itself. So these are again certain new things that would be available and may be utilized in a greater extent. Now, the biodiversity is definitely my concept of biodiversity is something different. I would like to see more genetic potential that available because of the biodiversity should be utilized for our crop production and crop productivity. It's a tremendous rich resources available in the country, and we must use them for a better crop before it is too late. Now, one example here, I can show you that today is the pulses where we cannot increase or could not increase the productivity of the pulses. It is a very, except the last 2 years, which is a bit of combination of many things. But in general, we are struggling to improve the production to a greater extent. The pulses that we're using, they has a very narrow genetic resources, genetic sources. And there are other clusters available in our germplasm where it can be very different genetic resources, genetic diversity is available that need to be combined, which is, we call it as a pre-breeding. A pre-breeding combinations with the genetic resources should be incorporated so that we can develop a better pulses crop for our future. And good thing is that ICRISAT as well as ICR both published PGNP genome sequencing, which is also chickpea is coming, maybe this month. Chickpea genome sequencing data also would be coming. That would allow us an understanding of the genes that present, or the QTL, or the genome-wide association mapping population that we could generate from that studies. And now this would allow us that from genotype to phenotyping, and what we started already, the NBPGR took initiative where 18,000 chickpea now grown at the different conditions of the country. Similarly, 22,000 wheat germplasm now being grown in the country. The two ways we would be looking, one is that our breeders, our other discipline people would find certain particular phenotype, either architecture of that plant, particular plant, or it could be drought tolerant or heat tolerance or even high yield or particular another trait. And then with the genome sequencing data, when we would be linked with this phenotyping, we would get a second generation of our plant breeding that I believe that would be accelerated plant breeding to come in next decade. This is already certain work is going on at Cornell University. Suzanne McCouch and other people started already based on DNA chip and the slide available with all DNA information of the rice genome sequencing data. These are single plant with a small, tiny pot. There are thousands of plants that can grow in greenhouse, and they would be connecting with the genotype to this phenotype, as well as see the trait and yield, and find out what combination of allele, what combination of genes that work in giving a particular character. And that's the way that material can be selected, and ultimately that will be taken to the farmer's field. So many of the farmers' work in future, what earlier 10, 20 years it took for the breeder to select a phenotype, that could be done now in 2 to 5 years in the laboratory, and with less cost. Of course, the initial investment is high, but later on, once it is standardized, the work can be extended to all crop plants, and ultimately that is the one way that we would be moving for the future. As Professor mentioned about the C4 rice, for 10, 15 years, Japanese scientists started the work on that. We started after that. We showed that it enhanced photosynthesis. We already know that the genes, the C4 genes present in the maize as well as sorghum and other millet plants, if incorporated in the rice is a C3 plant, and that can survive. And definitely, as Professor already elaborated, that it has the advantage of it can survive with low light as well as with less water. And only problem would be with the high temperature, whether how we can challenge that one. We might need to engineer it in a different way. But there are a lot of work going on, and I believe in 12-fiber plan, we would be taking 2 projects at ICR. One is C4, and one is biological nitrogen fixation. Now, biological nitrogen fixation is well known for the legumes. Leguminous plants can fix their nitrogen without adding any fertilizers. And whether the C3 or other plants, particularly non-leguminous plants, can also fix nitrogen. All the non-leguminous plants, including rice, do have all the genes present in legumes. So there is a homology of the genes present in rice. If these genes are present in rice must be doing something sometimes, maybe 100,000 years back or 1,000,000 years back. But probably the adaptation, the way we adapted the material, the way we selected the material, these genes become inactive or non-functional. We can activate those genes by different methods, not only a transgenic method, but at the same time marker-assisted breeding or cisgenetics, and we can activate those genes and as well as allow to provide particular strains of Azotobacter and Rhizobium, the bacteria that fix nitrogen, even without nodule formation, association with the rice roots or wheat roots, they can substantially supply certain amount of nitrogen. Even if they supply 10% in next 5 years, 20% in next 10 years, I think that would be great, because the most of this nitrogen would be available to the plant, and we can avoid lots of fertilizers, excessive use in the environment, and that could be one way that we can help our soil fertility as well as the crop productivity. Now, this is one thing, again, I'm coming back to the end of my talk. It is nothing to do with the GM, but it's just a canola field, either GM or non-GM, canola field, corn field, all the fields in US, Canada, Australia, every other countries, even now today Brazil. We cannot compete with Brazil in cotton either, even cotton without BT cotton. Without BT genes, Brazil can grow intensively cotton, because they are growing now cotton in a very intensified manner. So they won't allow weeds or any other things to come. It's a total different practice. We don't have that luxury of that larger land, so we cannot think about that one. But we have to design our way that how we can address that issue. At the same time, economic aspect must be seen. If we cannot connect with the market, if we cannot connect with other higher production and availability, then our farmers, I do not think that they would see a better economic gain. Now, the Science Congress, definitely there was many issues discussed, what we would be discussing here and today and tomorrow. And just one issue, I put it here, what Prime Minister mentioned. The complex issues, be the genetically modified food or nuclear energy, cannot be settled by faith, emotion, and fear, but by structured debate, analysis, and enlightenment. A scientific approach and understanding of these issues are, therefore, as vital as our core scientific capabilities. So, and India's young must adopt a science-based value system. I think today's morning, all the three speakers, they were mentioning about all of the things what our Prime Minister mentioned in his address. This is my last slide, I guess. I think this one, I took it in Bangladesh. One of the trip that I took it, there was religious practice there. And it came in the headline news in the newspaper. And it says that Allah spread rice in my village. So somebody asking, some people did not go to the religious festival. And they are giving free food. And they said that going there, I have to spend so much money and time, and I'm so old, I cannot go there. So if God is so kind, so asking God, why don't you just give rice here so that I don't need to go and spend, or I don't have anything to spend, so I can survive. Now this is one issue, and the thing is that definitely, it was also mentioned that more rice or grains, potato, less price, and less rice, and everything we get, more price. In either way, it is affecting our farmers. I think as Professor Abhijit Sen is sitting here, Professor Swaminathan is sitting here. So we need to see that how it can be connected with the market, and that insurance of the farmers, what they produce, they can get it. This is the last slide, the entire scenario that what we have today, all the tools available to us, what we're using in different countries. We have reached to the potential that the way we think, the way we can utilize it. And the way the US think or US utilize it. Now, we need to learn from all these countries that how they are using, what tools are available to us, what best agriculture practice we can have it. If there is something, even a bit of risk, taking a changes, should we not adopt those changes, at least to try as an experimental basis that how we can address those issues and can change our agriculture scenario today. And as knowledge-based agriculture, that China today, not only Beijing Genomic Institute putting global genome sequencing service, they have put 1,500 young scientists to work only on bioinformatics, and they are in future definitely aiming to give the global bioinformatics service. The knowledge-based or ICT in agriculture, all of these things together, this is a very important component. One thing we learn from one plant, either it's a science, it's genetics, physiology, on genomic-based or genome-based data with the synteny, with the similarities, and we can dissect out and can apply those things for other crop plants. More we have utilized that knowledge, faster we would move and do our job. So farmers ultimately need improved seed or quality seed, and what they're expecting from the country is the economic return, what they produce. And the future, that what we want, that water, nitrogen, phosphorus, use efficient crop, nutrition enriched, and higher productivity. From our side, scientists have to provide that one. Science and technology must improve livelihood of agriculture-based people with the help of policymakers and long-term vision. Without long-term vision, nothing will work. And ICT, knowledge-based agriculture, must be utilized, which I mentioned in my presentation also. I raised those issues. Site-specific manner. For a particular state, a particular places, we might need a very different agriculture, very different crop, and duration of that crop. And eventually, if we can optimize those, we would be serving in one India anyway. Thank you very much.
I think I just remember September 2nd when he made a similar presentation, keynote address in Mysore in a similar occasion. It was the media, in media coverage, he dominated. So many points he touched there. Wonderful presentation. There is scope for a few comments, questions, or reactions.
I'm not expert on that. I'm sorry. This is, I cannot. Labor, only from science point of view, I can address that we need to develop the farm mechanization in every crop. You take it cotton, you take it rice, you take it wheat, Jute, in most cases, I think labor cost is today 30 to 40%, and that costing farmers quite heavily, and sometimes they are not getting it. The labor cost can be minimized by mechanization and applying certain system, and that can help. I think science also can give us right type of crop, and certain farm mechanization can help to reduce that problem. And I think that has to come. That has to come. That also a part of economic improvement of our agriculture. If they can afford, that means something they are doing better. Which is my assumption, I may be wrong.
Anybody else like to? Yes, madam.
Yes, I think early nodulin promoter and as well as certain other lipoglucosaccharide based those genes are present in rice, and they are in many of those genes that are 90% plus even homologous to the genes that fix nitrogen that are available in the legumes. So the legume genes and rice genes, there is a homology. And many other plants, it has been seen that homology is there. Now, if this homology is there, the genes are present, and that genes are not doing anything. So that's the question, it's a hypothetical question that I raised, that the genes may have some function or might be doing some function, and they are not doing it because they don't need it. You are feeding fertilizer all the time. Why these genes? And these genes, the one thing is they need extra energy to fix the nitrogen. So it is a cost for the plant. It is a little bit extra cost. Even as we like easy way of living, plant also have the similar thing. If plant gets the energy from other sources, why should they utilize more metabolic functions and require extra ATP to fix the nitrogen? So they took that simple pathway not to use it. But if we can activate those genes and supply these bacteria that fix the nitrogen with the nodule formation, the nodule formation may not be possible in rice. It might be, I'm not sure, but it might be also possible someday. But at the same time, still this bacteria in association with the rice, when they come in contact with the rice plant in the root, the plant perceives that this bacteria is there. In response to this bacteria, those genes should be activated. And those genes then with the bacteria, those genes and the bacteria, then they would trap that nitrogen, atmospheric nitrogen, and convert it to the plant system. So there are many works, even we also involved in this work. We also published a few papers on that. And European groups are very actively working on it, but again, we need to revisit that entire system and like to see that whether this can be revisited. It is excellent if it works. I believe it will work. I believe it will work. Yes, please.
Yes.
Sir, actually we are inducing the activation of this gene, right? So if we are activating the genes in rice, of course we generally say rice, but there are many varieties which have different nutritional values. So is it applicable to all the varieties, or are we going to generalize one particular variety which is applicable to all kinds of soils throughout the country?
There are earlier works that International Rice Research Institute had a 10-year project on that. India was involved in this project. And there are groups in India also actively involved in looking at even rice varieties, different rice varieties in association with the different bacteria, whether they add some nitrogen in the plant itself. There are already some indication they do. There is a specificity. There are certain plants, it is always certain genotype would behave a bit differently. And at the same time, as you know probably, that the perennial rice, many perennial rice, they have more nitrogen fixation. It has been shown that they don't need more nitrogen. Of course, you may say that they don't produce much either. So it's a different thing. But there are already some study conducted. But I think when this study would be taken up, depending on the interest of the different groups, and it would be a networking across the country. Many state agriculture university microbiology department also would be involved in it. And then if they have interest on looking into that aspect, definitely we would be looking into this. But we need to first develop a proof of concept. A proof of concept, even it doesn't matter, any rice plant or any non-leguminous plant, and if it works well, then we can understand the mechanism, how it works. Once we understand it works and how it works, we can definitely translate it and scale up it for a bigger picture with the high-yielding varieties. So it is a question of how you like to see it. Once we see it, the proof of concept can definitely can be translated and scale up.
Thank you. Okay, I think I will take only 1 minute. Dr. Datta's session, design plant breeding with time. He quoted the example of corn and rice, how they received higher investment and how the returns were very paying and all that. And also biofortified food crops. And he also mentioned about seed world market, what is the contribution of India, and gene for efficient utilization of nutrients. He mentioned particularly phosphorus and activating nitrogen fixation genes. I think very useful. There are many such things he covered. I don't want to at the end make my remarks, so I am completing time itself. Wonderful presentation, Dr. Datta. Let us give a hand to Dr. Datta for his excellent job. Now I request Dr. Indush Sharma, Project Director, Directorate of Wheat Research, Karnal, Haryana, to speak on research, policy and institutional dynamics in enhancing wheat production and productivity in India. Dr. Sharma, please make your presentation.
Thank you, Dr. Mahadevappa,
Yes.
Chairman of the session, and our Dr. Hegde, Dr. Hegde, and then Dr. Datta, DDG Crop Science, Dr. Abhijit Sen, my all colleagues from ICR, students, and really nice to see so many women here. Most of the time we really don't see. So I think it's really fortunate enough that there are plenty of them. So first of all, I am glad to share with you that we had a record harvest last year, 93.9, and the topic is just best suited how with the research, policy and institutional dynamics coupled with the farmers. So it is the farmers, who work very hard in the field, so we could get it. Such a production. यहाँ पे close, yeah. So, where do we stand in India? Where India stands in the world? It is 14% of the total production. And second, we say that one per day productivity. Just now, somebody was commenting, even Dr. Swaminathan was saying that we need to enhance per day productivity, and already we are there. China has more than 150 days old crop, whereas we don't, we have 140 or 100 to 140 ranging between that. So 1 day productivity is very high in India. So where we are today, our average productivity is 3.14, which is slightly or marginally higher than the world average. And last year we had, 8% increase in production and 5% increase in productivity. And why this has happened? It was breeder seed, 29,000 quintal of breeder seed of 167 varieties of wheat and 1,900 quintal of barley seed of about 40 varieties. And then there was awareness program for the varietal replacement in those areas where we had a problem of stripe rust. Then timely sowing in basmati area, because we have the zero tillage, minimum tillage, conservation agriculture, where we could sow timely. Then extensive program. Dr. Datta had also made one committee for that how to go about it. At Northwestern Plains zone, which is high productive zone, we had high yellow rust and we could contain it, and marginal increase in area, and then exceptionally prolonged cool weather. So coupled with this, cool weather is very, very important at the grain formation stages. There, the awareness program, we cannot take up alone. So ICR, State Extension Machinery, and National Food Security Mission, and SAUs. So this slide you can see, if you see this graph, this is the grain formation stages, and you see the lower temperature which had happened last year. Now, today we can talk about what to harvest this year. And from where to harvest? Where are the options? So we have the options from Uttar Pradesh, large area. You see, large area we have. Then Madhya Pradesh. We already have a saturation in Haryana and Punjab. Already the productivity level is 4.8 to 5 ton. So only marginal increase could be there in Punjab and Haryana. Only what we can see is some cotton area where we can have some relay cropping or some other technology or things that we can have higher productivity. But then UP, Northeastern Plain Zone, Bihar, where we have more area, we are targeting this year to get more production. So as since morning, everybody is talking, Dr. Swaminathan, Dr. Abhijit Sen, Dr. Yappan. So, we have to feed the population. And where we are today, present stock is 37.6. Sir, we must export. If we can export 10 million ton of rice, why not 5 million ton of wheat? And this, I need not explain, every speaker has talked about all these problems, but then we have to have 100 million ton by 2020. And how we are able to achieve? Yes, sir, I am speaking that 2020, 100 million ton. Yeah, this is what Dr. Datta says, because we had a vision 2030 and we wrote 100 million ton by 2030, but in a meeting Dr. Datta says, why can't we have in 2020? But then, we are projecting our vision document, sir. So this is the fertilization, these are the interventions. Yeah, exactly. Sir, fertilization, rust, yield gap, farmer training, then disease resistance, genotype into system and product specific varieties. So here, we'll talk in detail. Hybrid wheat. Yes, Dr. Madhavappa was there and we had a lot of discussion on hybrid wheat. We have developed some CMS lines, and because my topic is very extensive, I cannot present the scientific data in that. We have the seed production standardized. We have 15 to 20% heterosis. Only thing is, and large field level, if we can have 10 to 12%, I think if it could work in rice, it could work in wheat as well. So we have resource use and efficient genotypes, and new innovations has to be, like transgenics we are talking about. So now we will discuss individual topics, research policy institutions. When we talk about research, we know what do we have, where are the opportunities, and where do we lack. So Indian Wheat Program, it's a model in the world. Very strong coordinated program, strong research and development, suitable varieties for diverse agroclimate. Agroclimate, of course, we have divided our country into 6 zones, but we find that there are certain blocks where we need different type of varieties and different package. Genetic diversity is available, suitable agroclimatic regions for growing wheat, wheat rust pathotyping. This is very, very important. We are addressing this problem for the last 40 years, and we are fortunate enough. Our neighboring countries had epiphytotic of rust, but we never had. It was localized problem with us. Then off-season nursery for faster breed weeding. Then double haploid we are talking about. Then strong international linkages we have. And what do we have today? We have already released about 399 wheat varieties. We have the genetic stocks available for almost all the traits, and only thing we need to do is to transfer heat tolerance, drought tolerance, nitrogen use efficiency into our high yielding lines. So all this, need great investment. The stock crop protection strategies, eco-sustainable production technologies are there, adequate breeder seed production is there, varieties are there, and just elaborating on these when we talk about varieties. Varieties we have for timely sowing, irrigated condition, for rain-fed condition, for restricted irrigated conditions, for fitting into different cropping systems. Then morning also Dr. Yappan was talking about the laser land leveler. 10 to 15% higher yield. So custom hiring is another thing which policy need to work on that how it could be extensively spread in the fields or for the farmers. 3 to 4% more area, 10 to 15% water saving. So such type of interventions are really required in future. But then the science component is already worked, technology is already there. Only thing is that it has to go to the farmers. Then improving soil health. We are talking about green manuring, crop residue cycling. Then we have all sort of machinery for this. But then we must talk about diversification pulses. And just now Dr. Datta was also talking that we need to have those crops in between there. We can have the nitrogen fixation done. So this is the resource use efficient, some tillage practices, some residue management, And then the precision farming we talk about, normalized difference vegetation index. So can farmer use it? How to provide such type of machinery that they do not overutilize the fertilizers? So all these machinery and all these equipment has been worked out, standardized, only it need to go to the farmer's field. So this is the science, residue incorporation, this is terminal heat minimization. The temperature is lower. So you see, this is how just by residue retaining, only thing what is required, Department of Agriculture need to work with the farmers, provide the machinery, do the residue incorporation. Two things we will achieve. One is the timely sowing, another is the moderating the temperature, moderating the terminal heat. Then we talk about all these technology, then we talk about value addition, iron and zinc, and we have all product specific varieties. But where is the market? Where is the industry? Who will have the linkage with us? All these traits, whether you talk about pasta, whether you talk about bread, bread we are lacking because in India, the crop at harvest is subjected to, exposed to very high temperature. So that type of gluten, it gets degraded. So we cannot say that we can produce wheat with high bread quality. But for all other traits, we have wheat with high gluten strength, pasta, semolina, recovery, and all other traits we have. Only thing is we are looking for the market and then enhancing bioavailability of iron and zinc. The science component has already been expressed by Dr. Datta. So genetic improvement, what options? Now 12th plan we are talking about, there was that what flagship programs you should have. So one was the pre-breeding. Pre-breeding will take care of everything. Whether you talk about resistance, you talk about yield enhancement. So that is the component, not in one institute, but in all the sister institutes, we must have the strong pre-breeding program coupled with the churning of germplasm. 25,000 germplasm NBPGR, it had sown in 3 to 4 locations, and we could really have now 1 to 2,000 lines which are with different specific traits, and then again we are shortlisting them so that those could be utilized widely in different states. Then hybrid wheat, integrating high throughput genotyping for precision breeding. Then genomic selection, phenomics for marker support. Now when we talk about phenomics, how many centers are there with phenomics facility? We don't have precision phenomics. We are talking about heat tolerance, we are talking about drought tolerance, but where is the facility? So we require all those facilities with us. Enhanced photosynthetic efficiency, we require money for this because till today I must admit here that wheat program is thriving on the conventional breeding program. Whatever today we have achieved, it is based not on the high throughput research but based on the conventional, but how long we will sustain and how far we will go with this. So now is the time that we really need some high investment to have a great jump. So this is the vigilance we need to continue. We talk about, okay, we have to list 3 or 5 points. No. But then our country is agroclimatically diverse. We need to address all those minor issues. Simultaneously, we cannot ignore those issues. So we have to address those issues. We have to have some continued type of work, which we are doing for so long. Sometimes there is a criticism that still you are doing the same work. Yes, we need to do it because we have to cater all the regions. We have to cater to all the problems what we are facing. But beside that, we need some high throughput science. So vigilance against rust, testing of new molecules against different diseases, then Carnarvon, now we have surplus, we must talk about some countries, they demand Carnarvon free wheat, then creating national repository of pathotypes, and even we must think about our neighboring countries. Airborne diseases, they don't have political boundaries, they are coming to us. So can we think of having some facilities for this? That we also work on the races, US, Dr. Chen, he is having almost all the races of the rust which is available in the world. And immediately they will know what genes do they have. But we are not even able to do even work on our neighboring countries. So devise eco-friendly management diseases like integrated pest management. So you see the impact of science. We had a collaboration with ACIR, Australian component. We were just marker-assisted selection. Very simple technique of molecular biology. We were just doing 4 years ago with 2 or 3 genes. And now with so many genes and so many other additional genes we are working. But in how many institutions? PAU, IRI, and now DWR started. Why not Harvard can work on it? Why not Indore can work on it? Why not Sabor can work on it? So, all these things are required today when we have the markers available. Then we talk about public-private Shabna. Of course, we have got some, but then we need to extend for the quality work. So we have to focus on bridging yield gap. This is a real issue of policy, harnessing higher production from states having low productivity, use of new biotechnology, high throughput market analysis, strong domestic demands from processing, value addition, and then we must think about what need to be done for export. So what challenges we are talking since morning: climate, deterring water scarcity, vulnerability to, then global pricing and subsidy. This is a policy issue. Population pressure, this is also a policy issue. Who is talking about this? How long to continue to say that population will increase and you have to produce more? Then reducing farm profitability, patent regime hindering genetic flow. This is a serious issue, We can get the material from anywhere. There are so many constraints. We cannot send our material. A scientist cannot go to any other country carrying his own material to work on it. So you see the problems. This is our country and these are the problems. And we have to cater to all these problems. And we are catering. That's why we are harvesting such a high. But then how long? Without investment. You see today where do we stand? This is 3.1, only 2 states, and this is Rajasthan coming up. Uttar Pradesh, large area, still not the national average. How to have national average even in Uttar Pradesh, Bihar, and all these states where we have large area? We can do it. So this is the policy. So policy is required for by the government, research and development, private, farmers, institutions, and for extension. We require policy for each and every aspect. Major interventions required in policy are the higher investment in research, converting frontier of science to applied. What does it mean? It means Dr. Datta was talking about the genome sequencing. We are talking that 96,000 genes of wheat has already been explored. This is a paper in Nature just 20 days ago. How to use that data in our applied search? Nobody knows. Where is the planning for that? Just few months ago, we know leaf rust pathogen has been sequenced in India. How to utilize in applied research? How many institutions can utilize that study and can apply it for the development of wheat varieties? There are 3-4 high science institutions in our country, or you can say 10 are there. But then how to apply those high science information into the real applied work? This is very, very important. Public-private partnership, procurement based on quality to enhance export, adopting international grading standards, and how long to continue giving the MSP, same as MSP to all the grades of wheat. If we are talking about, So decision support system, pricing, market situation, and weather forecasting is required. So policies for adoption of technology, strengthening extension programs by State Department. Just now in the morning, Dr. Abhijit Sen was saying that 30% cut was on ICR because it was given to states. But you see, where are we? If the cut is on us, why can't there be a separate funding for that? Timely availability of inputs along with credit, infrastructure and communication development, roads, mandis, market storage. Why UP is not harvesting more wheat? Because many of the farmers say that there is no place where can we carry our product and where to get the assured money, assured market. More production units for farm machinery targeting small farm holding. This is very important. How many farmers have less than 1 hectare? Even some farmers have 2 to 5 acres of land, but they also want to sustain. Then, so we have to talk about farming system, cropping system, whatever, inadequate storage. This is a serious issue. At farmers level, we are not even thinking. Even ICR has not been given this mandate to talk about storage, science related with storage. At national level, silos linking with intensive rail network. There is no country having such a good rail network. Then why we can't have silos along with that we can transport wherever we like for export? So this is the impact of MSP. You see, sometimes the area gets increased when you have higher MSPs. So increased MSP leads to enhanced crop acreage, MSP plus incentives to states where local taxes are exorbitant in wheat procurement, extending MSP in other states for well-structured marketing. Deficiency price payment in states where MSP not considered. Means they are not able to sell at the rate MSP is there. Then declared price difference on wheat grades. Staggered MSP. This is one concept. You know, one scientist was discussing. Yesterday I was discussing with a scientist from PAU. He says, Madam, if we have MSP in June, 1350 rupees, and in July, it is 1400 rupees, just a gap of 50 rupees. Next year, some of the farmers who are progressive will think that let me have 50 rupees more per quintal. Why not to have my own storage space? Means such type of experimentation could be done by the policy makers to motivate the farmers, to let the farmers think something beyond routine. Mean, I don't know if I am right or wrong, but then these are the things, you know, which come into our minds. Then tapping the global demand by adopting grading and standardization in the procurement centers, planned and committed export. So planning has to be done, and we have to say, okay, whether we have to import or not, but we will be exporting. We have to say this. Then seed production issues, private sector participation is subdued, high volume, low value, low profit. So Department of Agriculture intends not fully representative seed trade, then lower profit margins. You know, the private player doesn't go for crop like wheat. When the variety is released, only then he gets some profit. Then subsidized seed availability, that also hinders the private players. Seed replacement rate is not an end in itself. Seed replacement needs to be a vehicle of appropriate and timely varietal replacement besides delivering disease control and vigor. So this is fertilization policy. I think already discussed. We need to have a policy for this so that there is a balanced fertilizer use. Then there is a timely availability of fertilizer. Many states, they do not get fertilizer timely manner. So fertilizer pricing is, and then subsidy is a issue. Then transfer of technology, yes. Participatory approach, market intelligence is required so that farmer can think beforehand what he has to sow. Then develop for increasing wheat productivity, bulk SMS, voice mails, toll-free call center, bridging yield and knowledge gap. So this is, you know, yield gap and estimated production. Just by bridging yield gap, 14 million ton of wheat could be produced extra. So this all require policy. You see the slide? This much yield gap and estimated additional production. Means we have the technology, but there is a yield gap. So this is just, everywhere I show these two cards. We had a problem of stripe rust. Small interventions can help. We thought that stripe rust is appearing in Punjab and Haryana in after second week of January. But when these cards were distributed to the farmers in their local languages, now we know that by end of December it is there in one or the other field, and which is the area where it strikes first. So all these small things, they work. And now because of export, we are also trying to mobilize the opinion of the farmers to have Karnal Bunt managed through these cards. So wheat export potential. This is, if you see globally, in 2012-13, 40 million ton could be less production at the world level. The decline is on account of lower yield in European Union and Kazakhstan. And world stocks of wheat that were hovering around about 200 million ton, there will be less than 25 million ton. So now we have great scope. China is not an exporter. So India really can have a big market exploited for export, because now we are comfortably placed. So we have to see all the options for export. But what is the problem? That why we are facing problems in export? Because of the cost of production. You see in Argentina, price is $160, whereas our cost of production is 188. So this is the problem, Whether they are giving the subsidies and how they are managing such a low production cost, but you see the scenario of India. So we have very good international linkages. Simmered, and you see ever since 1960s, we all know germplasm exchange, then scientific exchange, then we don't have a disease UG99, a race of stem rust, but we are evaluating in Kenya and Ethiopia, and many of our varieties are resistant. Then all these conservation agriculture, then physiological traits, seed and heat tolerance. So all these things we are also working in collaboration. Then ICR, ACR, rust and other abiotic stresses, bioinformatics, water use efficiency, drought and root. We got very good jump plans from Australia with different RST genes, and we are working on this, that which type of root trait will be helpful for us for drought tolerance. Then water logging and other abiotic. There are large areas in Eastern Plains zone, even a part of Haryana where we have salt oil problem, then we have water logging. Then we are also working on the industrial quality. So these are the other institute collaborations, ICARDA, Indo-Swiss, then with the DRRW project, then Kansas State, Nottingham, France, then all our national institutes, then SAUs, Baramati, Delhi University. So all these linkages, we are working with them. So the Indian wheat program is really very robust, and I think with this program we can harvest, Dr. Datta, 100 million ton by 2020. So thank you very much.
One or two questions. We are short of time. We already enclosed 20 minutes of the next session. Dr. Hegde, please.
While complimenting the good work done by the institution, I still feel that the most important area untapped is use of water efficiently. What's the economics or feasibility of transferring the wheat growing area into micro irrigation instead of flood irrigation? And do you see any potential or any hurdle?
Yeah, just 3 years ago we started some experiments on drip irrigation and sprinkler irrigation. We could find that you can have 6% less water utilization, 5% increase in yield with utilization of sprinkler irrigation, precise irrigation system. But when farmers, they have large holdings, would it work? So that has to be seen, number one. Number two, where it has to be applied. I think the potential areas could be central zone and peninsular zone. So now we have a multi-location trial. I didn't discuss because the results were not there. In the peninsular zone and central zone, where this year we are having sprinkler irrigation and the drip irrigation system.
Yes, last question.
There are many advantages of hydroponics over the what normal routine of agriculture we do. Has anybody tried on wheat, means hydroponics technique and used for wheat production?
It's not possible probably. I think we'll discuss later. Yeah, it's not possible. Yeah. For experimentation, it's fine, but growing, you have large acreage under wheat. So I don't think such type of interventions could be there, but certainly for experimentation it could be taken up. It is taken up. Scientists are working, but experimentation under the lab. Yes.
So let us tell that.
Anu Sharma for excellent presentation.
Thank you, sir. It was tough for me to speak up.
Respected Chair, Professor Datta, Professor Sain, distinguished participants, ladies and gentlemen. I'm going to make this presentation on behalf of Dr. H.S. Gupta, Director IRI, who conveyed his apology for not being able to come here. Rice, as we know, is the chief contributor of calorie worldwide. 23% of the calorie requirement is met by rice, and 90% of world rice is produced and consumed in Asia, with India being the largest grower and the second largest producer of rice in the world after China. But when we look at the productivity, India stands at 59th position globally with 3.38 tons per hectare of paddy production. So that's a real matter of concern. The reason for this low productivity at the national level is the fact that the rice is grown in a varied ecology, 24.5 million hectare under irrigated ecosystem, but more than 50% of rice area is planted to fragile ecosystems where productivity is very low, and my friend Dr. Mahapatra will be addressing specifically to the fragile ecosystem, how to improve the productivity in those areas and what has been done. With all the constraints of the production, in order to meet the requirement for food, the paddy rice production has to be raised to about 185 million tons by 2030. And therefore, we need to enhance productivity because there is no scope for further enhancing the area under rice. There are three-pronged strategies, which I remember Dr. Swaminathan had proposed in 2000 in the Indian Science Congress at IRI that you have to sustain the current yield level, close the yield gap by providing appropriate agri inputs, and then setting up new yield ceilings, how we can enhance the yield further. And the various approaches which have been contemplated are yield genes from wild, new plant type exploitation using Indica japonica crosses, pyramiding yield QTLs, because many of these QTLs have been identified, markers are known, they can be pulled together from different sources, and then developing resistance to biotic, abiotic stresses, enhancing nutrient, water use, and radiation use efficiency, green super rice hybrids, C4ness, of which Dr. Datta made mention, and also biological nitrogen fixation. If we look at the yield gain during the period of Green Revolution from 1965 to 80, the yield in IR 8 to IR 50, if you see, there was a gain of 2 tons per hectare in productivity. But from that point onward, from IR 50 beyond, IR 72 and others, the gains have declined. It's about 1 ton per hectare. So this is one concern which has to be addressed. The various factors which are responsible for lowering down the production among the biotic factors in different ecology reduce the yield from 20% to 40%. And wild species, which are the reservoir of useful genes for all the traits which I have mentioned earlier, they have been utilized extensively, and they need to be utilized much more extensively with the kind of tools and technology that we have available in molecular biology. A battery of genes for biotic stress resistance, for bacterial leaf blight, 38 genes, for blast about 104 genes, and 341 QTLs have been identified. Likewise, for other stresses, the large number of these genes have been identified. The molecular markers are known, and now the very strong molecular breeding program has been launched by ICR in different platforms. Among the abiotic stresses, the submergence tolerance, which came from a land race from Orissa FR 13A, Indian land race. You can see on the left-hand side the crop on 31st of July, immediately after the flood has receded. And you see the crop after 2 months. On 31st October, the picture is taken, same field, it has recovered fully, giving a yield of about 4 to 5 tons per hectare. This is Swarna variety with submergence tolerance gene. Without sub-1, the yield would not have been there. Hardly you could get maybe 2 tons per hectare. But this gene has played a very significant role, and Swarna sub-1 is getting popular in the eastern India very fast. Another gene again from India, from Pokhali, a land race from Kerala for salt tolerance. Another important abiotic stress, which has been now being transferred in number of varieties which are being cultivated in salt-tolerant areas. The phosphorus starvation tolerance gene, which Dr. Datta mentioned, has become now available with the tightly gene-based markers available. Through marker-assisted breeding, this can be transferred. Likewise, for yield and yield-related genes, all these genes which are listed here, they have been cloned. And we have gene-based markers available for these genes as well as many other QTLs. And that provides opportunity for pyramiding these QTLs. These have been identified in different high-yielding varieties. And from each of these high-yielding varieties, if these QTLs are transferred, and to make a kind of super variety, which will have the grain number gene from here, grain size gene from here, salt tolerance gene from other variety, they can be pulled together to have the super plant varieties. Hybrid rice for sustainable food security is a very important option. But when we compare the progress that has been made in China versus India, with the release of about 59 rice hybrid officially, still the area covered in hybrid rice in India is just 2 million hectare. While in China, with 30 million hectare area under rice, 18 million hectare is covered to hybrid rice, more than 60%. So this poor adoption of hybrid rice technology has been because of several constraints. And these constraints are the level of heterosis in these hybrids which have been released is not very high. 2, the grain and cooking quality of some of these hybrids are not really acceptable. The susceptibility of hybrids to biotic and abiotic stresses. Then low hybrid seed yield and high seed cost. Thanks to the subsidy provided by the Government of India and National Food Security Mission on hybrid rice, that farmers are getting these seeds for 100 rupees a kg. Otherwise, if they had to spend 250 rupees per kg, they would never buy and use it. So this is a major concern. And the expansion of area under hybrid rice seed production, which needs a strong policy supports, along with procurement policy for hybrid rice. In some of these states, for example, Punjab and Haryana, there is discrimination in procurement. Hybrids are not purchased at the same rate as normal varieties. In order to enhance the level of heterosis at IRI, in collaboration with Dr. Mahapatra, we have carried out extensive exercise to classify the rice germplasm into heterotic groups based on molecular and morphological diversity, and this will help identifying heterotic combination in big way. Likewise, the new plant type based hybrids, which exploits the indica japonica sources with high grain number, they have high yield potentials in years to come. They will provide the solution as far as level of heterosis is concerned. Addressing to the concern of poor grain and cooking quality, in 2001 we released the first basmati quality hybrid Pusa RS10, which matures in just 110 days with average productivity of 7.5 tons per hectare. And this hybrid further we have improved for resistance to bacterial leaf blight, both the parental lines, and then for blast, and these germplasms have been registered with National Bureau of Plant Genetic Resources. With this hybrid, we also started a very effective public-private partnership with the Indian Foundation Seeds and Services Association, IFSA, and this was the first royalty turnover that was handed over to the Director IRI through the Minister of Agriculture. And later we extended this partnership to 18 companies. They produced the seeds for IRI for this hybrid. But what are the problems? At present, we are producing hybrid rice seed in about 60,000 acres area, and this 60,000 acre area is distributed in 6 districts of Andhra Pradesh, including Karimnagar, Warangal, Nandyal, Khammam, Nizamabad, and Kurnool. And because of high concentration of seed growers in this area, about 48 companies operating, same contract growers, they are growing shortage of land, scarcity of water, lack of proper isolation distances, then monopoly of farmers, and also cross purchasing. Somebody is getting organizing production, somebody goes, gives 5 rupees per kg extra seed cost, and he buys the seed in place of the person who is producing it. And therefore, alternative areas need to be explored for hybrid seed production, and in that Tamil Nadu, Maharashtra, Karnataka, Uttarakhand, Rajasthan, Haryana, Odisha, and West Bengal have a lot of potential for hybrid seed production. We tried in Haryana, and this is a hybrid seed production plot in Haryana for Pusa RS10 and other farmers, and subsequently this farmers turned into an entrepreneur producing the seeds. I will come to briefly the work that we are doing on basmati rice, integrating the conventional molecular breeding approaches to address the issue of sustainability and enhancing productivity. Out of 44 million hectare, about 2 million hectare is planted to basmati rice with an annual production of 6 million tons of milled rice, of which 3.2 million tons was exported in 2011-12, and 3.2 million tons and 2.8 million tons is domestically consumed, earning a foreign exchange worth 15,449 crores, about $2.64 billion. Now, how it has all happened? The traditional varieties of basmati rice, as you see on left-hand side, they are tall, about 160 centimeter. They are photoperiod sensitive, prone to lodging. This is the lodged crop on the right-hand side, and they have yield of 2 tons per hectare just. In 1966, it was Dr. Swaminathan who conceptualized the idea of combining the quality of traditional basmati in high-yielding background. And that's why the cross of Taichung Native 1, the dwarf rice, was made with basmati 370. And in 1989, we released the first dwarf variety, Pusa Basmati 1, which brought a sort of revolution in basmati rice production. In 2003, we released Pusa Basmati 1121, which is a sort of miracle rice, we can dub it that way, currently grown to 1.35 million hectare area out of 2 million hectare area, and contributing almost 11,000 to 12,000 crores per annum through foreign exchange. Farmers, this year prices have been extremely good. On an average, farmers got about 2,500 to 3,000 rupees per quintal of paddy for 1121. We have also developed another variety, Pusa Basmati 1509, which overcomes some of the weaknesses which were there in 1121. This has reduced plant height. It is 30 days early, and this is a major gain because 30 days earliness means it would save at least 6 to 7 irrigation in rice, and with the same saved irrigation, wheat crop can be grown for free. And also it produces less of biomass, and therefore the paddy straw burning, which is a major concern in Punjab and Haryana, can also be addressed. This variety doesn't have sattering, it doesn't have lodging, which was the major problem of 1121. And if you look at the grain and cooking quality of this rice, 1121 had a weakness of having a beak-like structure at the embryonic end. This did not give a very good table look. In this variety, we have tried to recover this particular defect, and this has excellent look, the smart look of grain and cooking. We work in collaboration with the industry because industry has to purchase rice from the farmers. If industry doesn't purchase, farmers will not grow. And industry will purchase if there is a consumers for that. So based on that, we have close collaboration with the rice industry, particularly basmati rice industry. And after developing these varieties, we give them for testing in their state-of-art mill, large-scale plant, whether this variety is suitable for your need or not. And that's how the president of All India Rice Exporter Association has certified that this variety stands better than Pusa Basmati 1121 in terms of grain and cooking quality, and it has all the potential to replace 1121. This is the field of Pusa Basmati 1509 on farmer's field. This year we have done about 50 trials, and the average yield has come from 6 tons to 6.5 tons per hectare with 110 to 115 days duration, and excellent grain and cooking quality. So overall, what IRI has done, as a matter of fact, in traditional basmati, that is Taraudi basmati, the grain length was not that long on cooking. Pusa Basmati 1 had better grain length. 1121 had still increased length. So this volume expansion of about 4.5 times, you cook 1 cup of rice and you get 4.5 times cooked rice, you can serve many plates. This was the major advantage that led to increase in the value of this variety and the export earning. At the same time, we reduced the duration from 160 days in traditional basmati to about 110 days in Pusa Basmati 1509. This was an unholy alliance between duration and yield. Generally, there was perception that longer the duration, higher the yield. But here we brought the yield up from 2 tons per hectare to 6 to 7 tons per hectare with 120 days duration. And then this has resulted into the Pusa Basmati 1 was released in 1989 when the export earning was 276 crore just. 1121 was released in 2003, and then since then you can see the export earning have gone to $2.64 US in terms of billions. So this has been a major achievement which has been rightly recognized by the government of India. Our two predecessors and mentors, Professor E. A. Siddique and Dr. V.P. Singh, both were awarded with Padma Shri last year and year before last. But there are certain challenges. For example, we have the problem of bacterial leaf blight. This is a picture taken on farmer's field. At the flowering stage, you have nothing to harvest. Then blast, this is neck blast in particular. And in order to prevent the crops from blast and blight, the farmers have to spray 4 to 5 times fungicides. And since it is a cash crop, they don't want to take any risk. They will definitely spray it. And therefore, the losses are not that big. If the farmers do not spray, then the losses will be really very high. But then this also leads to problem of pesticide residues. Brown plant hopper, you can see the number of insects per plant. And then this is how the crop looks after 2 to 3 days when the infestation of brown plant hopper has happened. But there are a large number of these genes available for these stresses, resistance to these stresses, and markers are available now. The plant breeders are much more equipped. And we started this breeding program in improved Pusa Basmati 1 for resistance to bacterial leaf blight in collaboration with Dr. Mahapatra. And this variety was released in 2007. We produced the seed in large quantity. We reached farmers next year of release and produced in hundreds of acres on the farmers' field the seed and made it available to farmers for commercial cultivation. So this is how there was a fast spread by involving the participatory seed production through farmers. Likewise, in Pusa Basmati 1 background, in order to prevent it from blast disease, we have transferred 7 genes and isogenic lines have been developed. And by crossing these isogenic lines, we will be able to pyramid these genes as well together in order to resist the blast pathogen, which is very difficult to handle. In doing all this, the major challenge has been the donor lines. None of the genes are available in the Basmati background. They are all present in the non-Basmati background. So when we use a non-Basmati variety to transfer these characters into Basmati, the quality gets impaired. As you can see here, this donor line has got red pericarp. On cooking, its cooking character is very bad. But in these lines, we have been able to recover the cooking character through extensive selection. Likewise, salt tolerance gene we have transferred in Pusa Basmati 1121, and the improved lines are as good as 1121, and soon these materials will become available for testing and cultivation. Now, Basmati is a commodity which is being protected by the government of India under geographical indication, and there are 7 states which have been identified as GI area. And therefore, in order to honor the GI internationally, we have to honor it domestically first. And therefore, the cultivation of Basmati rice will have to be restricted to the GI area. Although farmers outside GI area can cultivate, but they cannot market it as Basmati in branded form, they cannot export it. So we have plenty of scope for expanding the basmati area further. For example, in case of Punjab, rice is 2.78 million hectare at the moment. 7 lakh hectare is grown to basmati rice and 2 million hectare is planted to non-basmati rice. So there is a lot of scope that can be further expanded in Punjab as well as in Haryana. Now, there have been often discussion on whether rice should continue in Punjab and Haryana or not. If we look at the scenario, the total rice area is 3.7 million hectare, the two states put together. And these two states contribute about 10 million tons of rice to the public distribution system, because both states are not rice eating states. So whatever is produced, it goes straight to public distribution system and partly basmati for the export. And therefore 10 million tons of rice is a huge quantity, and it would be difficult to be dried in one go, but then strategies have to be seen how we can make it more profitable to the farmers. If it is withdrawn, what are the options given to the farmers? Unless we have a remunerative option as good as basmati, or even non-basmati, Punjab farmers are getting very good price, about 1300 rupees per quintal and 80 quintals yield. They are not bad with the non-basmati also. So the options are pigeon pea, maize, soybean and guar. But in none of these cases there is assured procurement price that is given by the government at the moment. So unless it is linked with the procurement, it will not happen that easily. Profitability of farmers has to be kept in mind. In part, there can be reduction, maybe 1/3 area can be diverted to these crops, and premium quality rice like basmati rice will have to continue in these states because of GI region. Another issue is the burning straw. In 2.6 million hectare, about 100 million tons of straw is produced every year. 3/4 of this is burned, about 80 million tons is burned. And this straw is equivalent to 35 to 40 million tons of coal. Now, while it causes the environmental pollution and several other associated problems, this can be used as a fuel for modern biomass plant. If these plants are linked with the state electricity grids and the power produced in these plants is supplied to the grids, it can serve as electricity source. For example, all the rice plant in the country, the most modern plant, the entire rice that they hull and mill, the husk of that rice is used for production of the power. And all these, the rice industry milling plants, they are based on their own power generation by husk. Likewise for this, and there is other options of biochar is another technology that is coming, possibly can be used for carbon sequestration using the paddy straw. Because at the moment for farmers it is very difficult to, even there are paddy straw binders available, but transporting it is so expensive and it is very difficult to use that as an option. So farmer has no option than to burn, and this has been highlighted. You can see these spots as the fire burning spots in entire Punjab. The picture was taken by NASA on November 5th, and the smoke that has spread to Delhi, almost it was not possible to see anything. So these are the health related issues like generation of severe smog, poor visibility, respiratory health problem, deterioration of soil health, of course, is an issue. Resource conservation technologies are a good option. It is happening, but slowly. And it is happening by force, because in Punjab and Haryana now the labor is not available for transplanting. Entire migratory labor used to come from Bihar, but because of Narega, local employment is available, labor is not coming in Punjab, Haryana. The farmers are forced to go for direct seeded rice. And DSR results have been very good. I am in touch with several farmers who have got with Pusa Basmati 1121 5 tons per hectare. And the cost of cultivation has been reduced in terms of water and energy input. So these are the various options available, and which some of these are researchable issues, some of these are policy issues which need to be taken on priority. So with this, I would like to close here, and I'd like to thank the organizers for giving me this opportunity. I would also like to thank all my colleagues and the students, the staff members for their wonderful support. Thank you very much.
Can we have 1 or 2 questions? We have overshot the time by 40 minutes. So if there are any important questions, please immediately come out 1 or 2 questions. No? So it was most enjoyable. I keep going and seeing the plants in his field, so I enjoy it much more. And I can say the world-class work. Nowhere in the world such a work is going on. I want to say that here, and let us give a hand to Dr. A.K. Singh.
Thank you, sir.
So now this session has come to an end. All the 3 presentations were very, very informative, well presented, and a lot of feeding to the audience. I think I thank the organizers for giving me this chance to chair this very important session where all the three speakers are stalwarts. And once again thank our rapporteur Dr. Hegde and also the organizers.